Hi friends, welcome back to Hobby Plus. In my snapper circuit analysis video, I told you can get 620 volt here. But someone don't understand why we get this voltage in this point and when we get this voltage. In this video, I just explain why we get 620 volt here. First of all, you have to understand if you have two batteries, something like that, and connection with series, that means this battery's voltage is 12 and that is also same. That means you can get 24 volt from minus to maximum plus because these batteries are in series. This is your power supply voltage 220. When 220 convert to DC with a bridge rectifier, that means that is your output voltage 220 into root over 2, that means 311 volt DC approx. Suppose we get here 310 volt DC respect to ground, that means that is your first battery and your second battery is here. Why it is your second battery? When it is your second battery? When transformer working as a battery. Now that is your pulse which is appear on the gate of this MOSFET, and also you have to understand that is your 50 cycles 50% duty cycles. Suppose this pulse is 40 kilohertz, that is your on period, that is your off period. Off period is equal to on period, so it is 50% duty cycles. When this voltage is 0, this point, that means MOSFET is off or in off condition. Now look at this, 310 volt come through this coil to MOSFET gate MOSFET drain. That means this time when this voltage is 0, this time you get 310 volt respect to ground. It is easy and normal to understand. After that, voltage goes to 12 volt. That means your MOSFET is in on condition. So in this point you get 0 respect to ground or tends to 0 respect to ground. Why we tell you tends to 0? Because there is RDS on, resistance are there, so it is not exactly 0 but tends to 0, very close to 0. In that time when this MOSFET is on, you forget the secondary part of this transformer. In that time this transformer working as a electromagnet, because you cannot get anything from the output of this transformer in that time when the MOSFET is on. Total electric energy transferred to magnet energy and stored in the core. When your pulse is off, that means your MOSFET goes to off, it is stored 310 volt between 1 and 2. That means that is your first battery respect to ground, and you get second battery in this point, that is also 310 volt because duty cycle is 50%. In this 50%, full magnet charged and you get 310 volt as a electromagnetic field, as a electromagnet. So one battery is here, another battery is there in series. That means that is your respect to ground, that is high, and respect to that point, point 1, that point is high. So it is plus, it is minus, it is plus, and it is minus. So it is minus, it is plus, it is minus, it is plus. So it is in series. Same circuit in that point make this circuit. I think you understand. That is your first battery, that is your second battery. So both batteries are in series. You can get in that time 310 into 2 is equal to 620, right? For that, when this time started, when this time is started, I want to mean this is the point you can get 620 volt. When this time started, you get output from this transformer, and electromagnet convert to power, electric energy. So this battery fully discharged, and second and when the second pulse is appeared, do same thing. That's why I tell you, you can get 620 volt in this point. I think you understand that. If not, please tell me. I also tell one thing. In my other video, someone told me I cannot get the output pulse, something like that. In that point, I must tell you, I get it, I test it in my lab, it is work. For that, we have to understand first one thing. When we choose our core, it is important for every frequency. Core must be support your frequency. How we test it? I already told in my video. Please check my channel. You can get this, how we test this core frequency. I have a core. This core below 100 kilohertz can do nothing. I test it in my lab. After 100 kilohertz, I get something voltage from the output of this transformer, because this core is support 100 kilohertz minimum. After that, you can get your voltage. So when you put here 40 kilohertz or 60 kilohertz or 80 kilohertz, whatever it is, you must check your test your core, or check your core, it is supported by this frequency or not. If not, you cannot get proper result. Core goes to high, heated up, and or so many noise pick from the output due to core, and core goes to crack also. So it is important. This person tell me that I think she is not check this core frequency, so get problem. And after that, I have to tell you something. If your core is support your given frequency and you get ringing outside of this transformer, that's why we use this Snapper circuit. I told everything in my Snapper circuit analysis. If you make your Snapper circuit properly, then you reduce your ringing from the outside of the transformer. Otherwise, you can do one thing. You do not use this Snapper circuit. You use here a bifilar coil, and how you use this, how you make this transformer, I tell everything in my last video. Check it, and I think that is the best way to remove the snubber circuit from your circuit, and you can avoid more problem from your circuit. Thank you. Please do this. You know what to do. Thank you for watching. If you have any question, please tell me in my comment box. I will answer you part by part.